Howdy! Let's talk about antiderivatives and the indefinite integral. All right, so here's the definition. We say that capital F of x is an antiderivative for little f of x if f prime is equal to f. Okay, example. Since 1/3 x cubed derivative, the 3 comes down but's killed by the 1/3, is x squared, we say that 1/3 x cubed is an antiderivative for x squared, or of x squared. Okay, another example. Since the derivative of the sine is the cosine, sine of x is an antiderivative for cosine x. Okay. Notice that each of these antiderivatives aren't unique. Namely, with the sine of x, I could have added any constant, and when I took the derivative, it would have died. So sine of x plus a constant is also an antiderivative for cosine. So, in fact, what we get is this. If f is an antiderivative for little f, then I can take f and add any constant I want, capital C, and I get the most general form of an antiderivative for f. Okay. All right. Now, it turns out these antiderivatives are going to be related to how we evaluate definite integrals. And therefore, we have the following notation. We'll see this when we hit the fundamental theorem of calculus. This is notation for indefinite integrals. The notation is this. If capital F is an antiderivative for little f, remember this just means that the derivative of capital F is little f, we write this. The integral of little f dx is capital F plus c. So notice there are no limits of integration. That's how you can tell it's an indefinite integral. And it really just means, when someone writes the integral of f without limits of integration, it means find an antiderivative. That is, find a function f so that capital F prime is little f. And we write the c because, in fact, you can modify an antiderivative by a constant and still have an antiderivative. All right. No one remembers formulas for antiderivatives because they're really just formulas for derivatives. Okay? But let's do a couple examples. Since the derivative of 1 over n plus 1 of x to the n plus 1, now when we take the derivative, that n plus 1 comes down and is canceled, and I just get x to the n. Now technically this only works when this denominator is not 0, right? Which is the same as saying n can't be minus 1 here. That means that this is an antiderivative for this. Now we write that with this indefinite integral notation. the integral of x to the n dx is 1 over n plus 1 x to the n plus 1. Again, n is not minus 1 here. It just says that the derivative of this is x to the n. And then try not to forget the plus c. All right, so that's one example of antiderivatives. Here's another one. Let's do this one. So let's take care of this n minus 1. So that happens when you want to find an indefinite integral of x to the minus 1. So since d by dx of the log of x is 1 over x, that's the n equals to minus 1 case, and technically x has to be bigger than 0 here to plug into the log. That means that the log is an antiderivative for 1 over x. So the integral of 1 over x dx, its an indefinite integral, is just the antiderivative, which is the log of x, plus c, at least for x bigger than 0. Now, if I want to repair this requirement here, what do we do if x is less than 0 and we want to find an antiderivative for 1 over x? Well, here's the trick. Remember, since x is less than 0, the absolute value of x will be minus x, right? At least when x is negative, because if you take, for instance, the absolute value of negative 5, it's plus 5, which means you've really just multiplied by minus 1. So if I do d by dx, the log of the absolute value of x here with x negative, well, since x is negative, this is just the log of minus x. And so now it's a chain rule problem where the outside function is log, inside function is minus x. So you take the derivative of the outside, 1 over x, plug in the inside, minus x, times the derivative of the inside. That derivative is minus 1. And so you get 1 over x. So that means for negative x's, this guy here, log of the absolute value of x, is an antiderivative for 1 over x. So you get this antiderivative. If you ever want to find an indefinite integral of 1 over x, the general answer is log of absolute value of x plus a constant. And this works either for x bigger than 0 or x less than 0. If x is bigger than 0, you can go back to that original formula we had up here. Anyway, that's another example of an indefinite integral. All right, see ya.